Hey class, this week we are going over arrays. We're going to be talking about both 1D and 2D arrays, as well as traversing them, passing through functions, things of that nature. So, what is an array? An array is a collection of items that have the same name and the same data type. So you can think of it as let's say you have four variables of type integer, and they can have different values. X1 is 7, X2 is 8, X3 is 4, whatever. Instead of declaring these four integers, you can actually kind of package them up into an array. So this would be a type int, and the name is xArray, and it has four elements in it, right? It has all four of the x values within that. So you can imagine that this keeps things convenient, keeps things compact. However, there's some quirks on how to access these different elements, which we will talk about. So to declare an array, you can do a couple things. There's actually a third thing that I will put in right now. Do that. All right. So the things that we can do are, one, you always have to put your data type, like anything else in C++. Then you put the name of your array, and then you put square brackets. And these square brackets is how you will tell the computer how big you want the array. Now in C++, the memory, and we haven't talked too much about memory allocation. We'll talk more about that when we get into pointers and stuff. But basically, at the start of your program, at runtime, I guess it's actually at compile time, your program will allocate a certain amount of memory and then deallocate that later in the program. With arrays, it has to allocate the memory at time of compile. So basically, when your program is compiled, it needs to determine how big is this array. And once that's determined, it's static. You can't change that. So if you say that int numbers is 5 elements long, you cannot later modify numbers to be 8 elements or 10 elements. You would have to create a new array to do that. So what you write here is set in stone. So right here, you put the square brackets and you're saying, hey, I want there to be 5 elements or 5 items in this array. This next example is you can actually define what those items are. So notice it's of type string, it's called names, and then I say, hey, I want this to be 3 elements long. What are the elements? Well, you put the curly braces, and then within the curly braces and delimited by a comma, you would put what these values are. So this would be the first one in the list, the second one in the list, and then the third one in the list. The third variation is very similar to the second, except in this case, I didn't put a number here. This is just a matter of taste and convenience. There's not a better way to do this. But basically, if you're going to be declaring your items right then and there, you technically don't have to put anything in the brackets. It knows that it's 3 items, right? You put 3 in here, so it's like, oh, okay, that's a 3. So once again, it doesn't matter one way or another, either one of these ways. I personally would probably prefer way 2 because it's just cleaner. Especially, like, imagine if you have, like, I don't know, 25 items. Instead of having to, like, count them out to figure out how big the array is, you just kind of have it right there. But anyway, yeah. So this first way is you're saying that the array, you're initializing it, you're saying it's 5 values, but you're not saying what those 5 values are. In ways 2 and 3, you are saying you're initializing it, and then you're saying these are what the values are. So indexes. So this is how you kind of traverse the array and kind of figure out where things are at. So in this case, we have an array of type string. Its name is students, and it is 4 elements, right? Jenny, Joe, Paul, and Fred. 1, 2, 3, 4. Now, you may have learned this with programming so far, but we as programmers are crazy people and thought it was a good idea to start counting at the number 0. So the index would be the position. Where is the value in the array? You would actually start at 0. So even though there's 4 elements, Jenny, oh, I apologize. Jenny is actually at index 0. Joe is at index 1. Paul is at index 2. Fred is at index 3. So it would be 0, 1, 2, 3, even though it is 4 elements long. And that's important because, if you wanted to print the value that's Paul, you would actually write, cout students, and then in the square brackets you would put 2, and that's how the computer would know, okay, we're talking about the students array, we're talking about index 2, which happens to be the value of Paul. So to iterate over the elements in an array, if you're familiar with working with lists in Python, you're probably used to the concept of arrays, and you're probably going to be pulling your hair out because Python made lists or arrays very easy. C++ is cumbersome with them. So if you want to print all of the elements in the array, what you don't do is cout names. That's not going to work. You'll see that if you do that, you'll actually get the memory address of the first element of the array. Anyway, that's maybe more detail than you needed, but you cannot just see out the name of the array. To iterate through, you actually have to print every index of that array. Now, you could do that by saying cout names 0, cout names 1, cout names 2, and so forth. That would be horribly inefficient and waste a lot of time and space. So the best way to do it is you actually write a for loop. So I have names of type string. It's 4 elements, and it's Bob, Joe, Phil, and Frank, right? What I do is I get a for loop. I'm initializing my little index increment. I'm setting it at index 0 initially. And then you set the upper bounds to be the name, or to be whatever the array was initialized at. So I'll put a 4, and then you increment every time. And then within that loop, I just cout, and it's names at index whatever, right? So if we walked through this, it's starting at 0. So names at 0 would be Bob, and then it goes to 1. Names at 1 is Joe. Names at 2 is Phil. Names at 3 is Frank. And then by the time I is 4, well, 4 is not less than 4, so you're done. So this would actually print Bob, Joe, Phil, and Frank. And this is the only way that you would be able to quickly iterate through every index and traverse the array. So the next thing I want to talk to you about is passing arrays in functions. So you may come across times in which you will want to write a function, and a parameter in that function is the array that you initialized. So let's walk through this example. We'll start in main here. We're printing out array practice. We have initialized our array, and notice I don't have anything in the square brackets. That is okay because I have defined the value here. So we know that it is 4 elements big. And yeah, these are the values, 1, 2, 3, and 4. Num at position 0 is going to be 1, right? And then we're going to call our change function. So let's look at that. So right up here, it's void, meaning there is not a return type. Change, and then we are passing, what are we passing in here? We are passing an array. Now, this is interesting. Notice how I don't put the size of the array in the parameters. You cannot do this. You cannot put that. That would not work. The reason for that is called array decay, which I will talk more on the next slide. But basically, when you pass in array as a parameter, it decays into a pointer, and it loses that the dimensionality of all those elements. Now the elements are still there. Num didn't go away. You just have lost that size. So in this case, you can kind of leave it alone here. We're not, messing with the size of the array, so that's fine. You can still say num0, and then this time I'm assigning it to 42. So instead of num0 being 1, I'm saying num0 is 42. So then we run this change function, and position 1 after change, num0, what would that print? That would actually print 42, right? Because in our function, we changed that value. So a little bit more about array decay. So it decays into a pointer. Now, we are not talking about pointers for a few more weeks, so I'm not going to get into the hairy details. But basically, it points to the memory address of the very first element of that array. And so basically what I'm saying is you can call out the other elements, that's fine. But let's say you needed to do something like print the array. A print array function would actually be pretty nice to use. But in order to do that, we would need to know the upper bounds of that array. And you wouldn't know that unless you kind of passed in the size. So what you would do is you still pass in the array here. Remember, don't put a number in here. But then you make a second parameter, and that second parameter is the size. So let's go down to the main, cout array practice num 1 2 3 4 print array, and I'm passing in the size, right? I actually did not write what the size was in this, so let me show you. So int, goodness, I hate that it does this. Int size equals 4, right? Because there's 4 elements in the array. So I'm passing in size, and then up here we have the array, and then we have the size, which is 4. So that's how we know what that upper bound is, right? I guess another way we could do it is we could just do that, right? And there you go. So that is how we can pass the size of an array through a function. It just needs to be a separate parameter. Okay, finding the size of an array. Now, if you're the programmer, you would know what the size is, right? You've initialized the array. You made it size 4. But there may be times and situations in which you need that size to be dynamic, or you don't know what it is offhand, things of that nature. And so it's a good little trick to know how to figure out how many elements are in an array. The way you do that is you use a function called size of. Now, size of you can use even when it's not in the context of an array. All that function does is tell you the size in bytes of how big your variable is. So you can do this with anything. You could take an integer variable, do the size of, and it should return back 4 bytes, because an integer is 4 bytes usually. So that's all that does. Now, how do we find how many elements are in our array? Well, you take size of array, right? So notice that when I just pass in the array here, I'm saying how big in bytes is my total array, right? That would give me a number, however many bytes it is. But then you divide it, and you divide it by the size of the array, and you pick a random position, usually 0, because you don't know how big it is, right? But technically, you could pick whatever you wanted; it wouldn't matter. But usually, best practice is 0. And what are we doing here? We're saying, well, how big in bytes is the array divided by how big is just one element of that array? And if you think about it, basic division, you take the whole minus one part, and that will give you how many times the pie is sliced up, right? It gives you how many elements there are. If you have, if the array is 100 bytes and each one is 10 bytes, then how many elements are in there, right? It would be 100 divided by 10, which would be 10, right? 10 elements. So that is a handy little trick, not always useful, but it does get more and more useful as you do more complex programming. Okay, two-dimensional arrays. So this is where we get into a little bit of mind-bendy territory. Same concept. I haven't lied to you guys thus far, but we're adding another dimension. So we're working with more numbers. We're working with rows and columns, and that can be kind of hard for us to wrap our heads around. Technically, you can go to the nth dimension if you guys are a data science major or have taken linear algebra. You're going to be working with this concept of having multiple dimensions. And when you create machine learning algorithms, it's going to have to work with all these different dimensions. Dimensions that our brains can't really comprehend or visualize. So just know it gets really, really, really complex. But with 2Ds, or 2D arrays, thankfully we can visualize this still. So it's basically a table. We have our rows and we have our columns. So if this was our array, val, if we do 1, 3, we're saying that it has 1 row and 3 columns. Or if we're looking at positions, it would be row 1, column 3. And remember, we start at 0, right? So 0, 1 would be our row, and then our column would be 3. So 0, 1, 2, 3. So if we wanted to get, a 2D array, if we want to know the position of 1, 3, the answer would be 6, because it is on the first row and the third column right there. So to reiterate that point, how do we find the index? Well, first, if we initialize our array, we're saying that this array has 3 rows, 4 columns. So 1, 2, 3 rows, and 1, 2, 3, 4 columns. So this is how big our array is. So what's the position at 2, 3? I'm going to pause for a second and let you guys think about that. What is the position at 2, 3? Okay, row 2, so 0, 1, 2, and column 3. 0, 1, 2, 3. 25 is the number. If we look at position, I should change this. What is the value at position? Yeah. Or maybe let's just do that. So yeah, so 25 is the answer there. Okay, so how do we initialize a 2D array? How do we, declare this thing in our program? Well, just like it's the same rules apply. You could just, put a semicolon here and call it good, or you can actually give it values. So here, we want 3 rows, 4 columns, and if you notice, this is just this example again. And then the curly braces. So you want a beginning and an end here. And notice how this is all formatting, so you can format it however you want, but it's good practice to format it like this, so you can kind of see what's going on. You can kind of visualize it as a table. So notice that within a starting and an end curly brace, we have a row of data here. And then outside of it, we separate by a comma, and we have a second row, then comma, and then a third row. So that's where our 3 comes in. Our 3 rows have a beginning and an end curly brace. And then the 4 is our columns of data. So notice that 3, 9, and 21 would all be 1 row. 13, 7, 61 would be a second row. 82, 50, 42 would be a third row. And 106 and 25 would be a fourth row. So if you do it like this, you can kind of visualize what's going on. Right here would be our rows, and then our columns would go straight down. So same thing applies, right? You could find an index and you could grab the value to any one of these numbers. Okay, so how do we iterate through a 2D array? Once again, the rules haven't changed. We've just added another layer of complexity to them. So once again, you're going to want to do a for loop. That's going to be the most efficient way here. But what you do is you actually have to nestle your for loops. So it's kind of confusing. It's kind of a mess. But the outer loop would be going over your rows, and the inner loop would be going over your columns. So remember, if the array is a 3-4, so 3 rows, 4 columns, then in our outer loop we want to start the index at 0. For I is less than 3, and then increment it. And then immediately after, within this outer loop, you want to declare another loop. And this goes through your columns, right? So I do I, J, and K for my what I name my little variables within my for loops. But you can name it whatever you want. If it helps you, you could do like row and column, right? Whatever works. I guess there's a little bit of linear algebra that carried over by doing I, J, and K. A little bit of vector stuff. But anyway, within this outer for loop, you have an inner loop. And then it's less than 4, because now we're talking about our columns, right? And then within that inner loop, this is where you would actually increment, or you would actually print out your array. So it's numbers, and notice that rows is my I, and J is my column. So it's at I, J. So think about this for a minute. We'll kind of walk through this. I is equal to 0. Okay, I is 0. You go in, J is 0. Okay, so this would be numbers at 0, 0. And that would be our first thing we would print. Well, then we don't move on from I. We're still in I here. We go to the next J. So I is still 0. Now J is 1. So it's 0, 1. Right? Then it's 0, 2. Then it's 0, 3. And once after 3, this for loop is done. So we break out of that for loop, and I'm printing. That's the end of the line. Now we go to the next line. Now I is 1. Okay, I is 1, J is 0. So we have 1, 0. Then we have 1, 1, 1, 2, 1, 3. Now J is done. New line. This is a 2. So 2, 0, 2, 1, 2, 2, 2, 3. Then we go on. Then it's 3, right? But it actually wouldn't be 3 because we would be done here. So that's how you would iterate through it. It's not terribly hard. You just need to sit and think about it. And I actually really encourage you guys to get out a pen and paper and just draw it up. I mean, it's hard to kind of remember all these positions in your head, but if you draw it out on paper, it's going to be so much easier. So that's it. That's all I've got on arrays. It does get a little bit more complex, but I'm not going to get into that until we get into pointers, because I've kind of contradicted myself in this lecture. You might have caught it. I said that you can only you have to initialize how big your array is at the beginning, and then later I said if you need to dynamically change it. So I kind of lied to you. You technically can change it, but that is going to require some manual memory allocation, which we're not going to get into for a couple more weeks. So just know right now, when you declare that size, it's stuck there. So really think about that when you're doing your programming. Anyway, as always, please let me know if you have any questions. I'm here to help. Good luck.